first I research optimizing indoor air quality through a driven ventilation system in education building. Like indoor air quality is the term used to define the condition of the air within and around the building. The primary focus on the health and comfort of individuals occupying this space. Like it encompasses various elements that collectively determine the quality of indoor air, including the presence of gases such as carbon dioxide, nitrogen dioxide, particular materials, and microorganisms. When there is insufficient flow, there is increased risks of indoor environment becoming breeding ground for pollutant carrying the virus like coronavirus, as fresh outdoor air is not adequately introduced to dilute this contamination. And the indoor air pollutant are not effectively removed from the ventilation area. According to statistical data from the World Health Organization, approximately 4.6 million people suffer to illness each year that are directly linked to subpar air quality. And another data, another data of World Health Organization shows that approximately 3.2 million people die every year due to the poor indoor air quality. So it's crucial to note that indoor air quality in any indoor indoor setting is affected by the factor like temperature and humidity, which can either mitigate the transmission of coronavirus and directly impacting the health, comfort, and overall well-being of the occupant. Indoor air quality is important in education building to ensure that well-being and performance of student. Like good indoor air quality is critical for student focus and efficient in economic activities. Like poor indoor air quality can lead to the sick building syndrome and health uh, complaint among the occupants. Students are more sensitive to unhealthy air as they breathe more air than their body weight and fast rate. Like parameters such as CO2, NO2, and PM25 voluntary and voluntary organic compound are measured to assess indoor air quality in classroom. And machine learning method has been used to determine the indoor air quality screening and update them to new indoor air quality standards. So considering indoor air quality in education building is crucial in for minimizing health risks and improving the student learning performance. What is the current challenge to maintaining the optimum indoor air quality? Like uh, inadequate ventilation, like a building design lacking the proper ventilation significantly affect the indoor air quality, leading adverse consequences on temperature, humidity, airflow, and accumulation of indoor air pollutant. This in turn gives rise to sick building syndromes, posing health risks to the occupant of the building. Another is presence of the pollutant. Like pollutant sources within the higher education environment in the UK encompass a wide spectrum, including the indoor air and traffic emission, construction and furnishing materials, cleaning suppliers, electric device, and various laboratory equipment. Furthermore, the deterioration of building heating and ventilation, air condition system during the aging, insufficient maintenance, applications result from the technological advancement also contribute to this array of source. And another one is environment viability, like temperature, humidity, CO2 concentration, and occupancy level fluctuate throughout the day, and this variation impact indoor air quality requires advanced ventilation system. So for the to solve this problem, we are going to introduce the AI driven ventilation system to optimize the indoor air quality. AI powered ventilation system like offer the real time monitoring, providing a comprehensive understanding of indoor air quality. This ventilation AI driven air powered ventilation can adopt the occupancy preference and optimizing comfort while minimizing the energy consumption. Like air driven heating, ventilation, and air conditions system that use real time data analysis and up to optimize the energy consumptions based on individual needs and weather condition and occupancy patterns. What are the research aims and methods? main, main research aim is to introduce the AI model for indoor air quality optimization in education building, and to meet this, the following we are going to develop the AI model and establishing a real-time monitoring, all real-time monitoring alerting mechanism, exploring energy efficiency, ventilation strategy, and ensuring the compliance with the regulations and enhance mitigation strategy like for the to fulfill our objectives following. I will use the following. My research methodology will be research will utilize the positivist positivist approach, and will use the quantitative method to explore and understanding the relationship between the indoor air quality parameter, ventilation strategy, energy efficiency, and compliance with regulation like evidence. Um, yes. First we need the data. We are going to collect the data collection, like for collection of data for sensor we'll use the sensor deployment. For my research person, the data will provided from the university. uh, yes. Then we'll use next step, we'll use the data pre-processing, like the data which is provided by university. We will use the data cleaning, normalizations, and future extraction of data collection. If any data missing or erroneous missing data point to addressing any missing data points to ensure the data set integrated, and we'll develop the AI models. First we'll select the algorithm, like we're going to consider machine learning algorithm that consists of neural network, decision tree, regression model. On the basis of data we'll select one algorithm and we'll implement with Python. And then another step is training and testing. We'll utilize the pre-processed data from AI model training and reserve some set of portion of for model testing and validation after, and some portion of data for the uh, training the AI model. And we'll use the cross validation techniques that assure the model performance. And then we'll use next one is real time integration, like embedded that AI model. Will use the AI model in education building ventilation system, like this is continuously monitor and adjust the ventilation parameter for design indoor air quality level. Another one is energy efficiency strategy, like strategy development, like we'll explore the energy efficiency ventilation strategy like factor considering like occupancy, outdoor condition, indoor air quality parameter, and simulation. Will simulate the study to evaluate the effectiveness in balancing the indoor air quality and energy efficiency. Compliance with regulation will ensure that AI driven ventilation comply with UK air quality rules and regulation. And mitigation strategy, like will investigation the integration of strategy like increase ventilations and mitigation assessment. For the will investigate the integration of strategy like increased ventilation and cleaning, assist their effectiveness in enhancing indoor air quality. And next we'll analyze the cost benefit analysis. um, will evaluate practically and cost effectiveness of implementing mitigation strategy alongside with AI driven ventilation system. And evaluation metrics will measure the research outcome using key metrics like IAQ index, energy consumption, and compilation with indoor air quality regulation and cost saving. What are the possible outcomes from the our research that were will first one is improve the indoor air quality, will reduce the contamination level, minimize the microbial presence, enhance comfort and well-being, like uh, uh, comfort and well-being. Another one, energy saving, like will achieve the notable energy saving in education building by optimize energy consumption, like next one is optimal energy consumption, like AI driven ventilation system, like expected to adjust the ventilation rate based on occupancy, outdoor condition, indoor air quality parameter, and in this project to result in reduce energy consumption while maintaining operation efficiency. By aligning ventilation with actual building occupancy, the research aim to eliminate the unnecessary expenditure and compilation with IAQ regulation, like will compile our AI driven ventilation system with IAQ regulation and guidelines specified to education building in the UK, and mitigation strategy. This is to assume the effectiveness of mitigation strategies such as increased ventilation or air cleaning, while integrated to further improve the indoor air quality and provide valuable insight for future indoor air quality management. And a demonstrative model, this model can be the blueprint for serving the for various education buildings, for enhancing the indoor air quality, energy efficiency in education building facility. But like potential challenge and mitigation, like data accuracy and quality challenges, like ensure that that the accuracy and quality of data collected from various and sensor or historical source, like mitigation cross validation, data validation process improve, like checking the data from the sensor, verifying the historical data collect source, implementing the stringent data cleaning and normalized process, and data privacy and ethics, safeguarding the data privacy and adhering to ethical consideration, including the informed consent and algorithm transparency. Mitigation, like challenge mitigation for this one is will still to ethical protocol and inform to the university. Informed consent will be obtained from all the stakeholder involved in data collection. Algorithm transparency will ensure to protect data privacy. Another, an integration of mitigation strategy, like effectiveness integration of studies such as increased ventilation, air condition, air cleaning, and AI driven ventilation mitigation, like simulation will be conduct to assess this effectiveness and potential benefit while combined with AI driven ventilation system. This simulation will inform the development of effective ventilation strategy. Like this, my research will address the equality, diversity, inclusion, like equality, indoor quality. Like my research prioritize equality by focusing on individual quality in education system. The goal is to create a equality learning environment for all irrespective of individual backgrounds or backgrounds are sensitive to air quality. Another is consider diverse occupancy, like AI driven ventilation to improve in this research at a ventilation rate based on the real time data, considering diverse occupancy pattern within the education system to ensure that all the to ensure that uh, this approach this approach will consider all varying health condition sensitive to occupants, ensuring that indoor air quality optimized for the well-being of all individuals irrespective of their circumstances. Like inclusive approach to comfort, like pr- ventilation contribute to more inclusive to and comfort atmosphere within the education building. The focus on enhancing the comfort aligns with the equality, diverse and inclusion value, positively impacting the learning and working experience of diverse range of students and staffs. This inclusive approach is critically for forecasting a sense of belonging and well-being. Accessibility to quality indoor space, like the research advocate for the idea that every individual, regardless of specific need and sensitive desire, access to quality indoor space. By optimizing indoor air quality, the this research will create an environment that are accessible to all, ensuring that the indoor space in education building are safe and conducive to well-being of everyone. Another one is research integrity in discipline. This research will integrate within different departments, like intersection of engineering and environmental science. The research integrate the principle from the engineering particularly for AI-driven system with knowledge from environment science, focusing on IAQ parameter and pollutant. This integrated approach a comprehensive understanding between the indoor environment and develop the effective solution. The next one, integration of building design and health science. Assessing indoor air quality involves like considering both building design and its impact on human health. And the research integrate the aspect of building design with health science to provide a holistic review of the span of multiple discipline. Another is collaboration across the UWL school and college. The project encourages the collaboration across the various UW school college, forecasting the exchange of idea and exchange of idea and expertise. This brings together insight from the this collaboration brings the insight from the engineering, environmental, health science, and potential architect, enriching the research with diverse perspectives. And next is research impact. So first impact will be health and well-being. That primary focus on contributing the health and well-being of students and staff, like improve indoor air quality, directly influence the public health, potentially reducing the prevalence of respiratory alignment and creating healthier indoor environment sustainability. Optimized ventilation system contributes to the energy efficiency, like align with environmental sustainable goal. The research aims to reduce the carbon footprint of education building and demonstrating the most aligning a commitment to the environmental responsibility. Education outcome like a comfort and healthy learning environment positively influence and education outcomes positively influence the impact extend beyond the individual to culture and social work, forecasting a generation that values sustainable and well-being in education system. Public policy and regulation. The research outcome can inform public policy and regulation related to indoor air quality standard in education building. By providing evidence-based insight, the research contribute to the development of guidelines that ensure healthy indoor environment for future generation. Thank you.